Web for Pentester 2. So now moving forward, we're going to the third and final part of the web for Pentester lab. We're gonna do the second exercise, which includes SQL injections, authentication, captcha, authorization, mass assignment, randomness issues, and MongoDB injections. So commencing first in SQL injections. Um, Some common SQL injections examples are provided. The first examples are authentication bypasses, and the other ones are more traditional SQL injections. So for the first one, uh, the goal here is to bypass the authentication page. This example is best known way to bypass an authentication page. It's even used in a lot of comics related to SQL injections. And let's see how the query looks. So a query would be like this. Username and password under our control, and the application would check that the username and password are correct by ensuring that at least one record is returned in the SQL query. And there are many ways to perform the task. The best way is to inject the username and password. The username and the password can be hashed or encrypted. So yeah, we need to keep in mind the OR operator. And yeah, we're moving on to the first example right here. So we're going to try to bypass this site. So we can use the OR and the hashtag for encoding right here. And we can add whatever password that we want. It doesn't really matter. And we click submit. And as you see, we've been successful in our first example attempt. So now moving on towards the second example, it's the same type of vulnerability, but with a twist. In the first example, the code only checked that something was returned. In this version, the developer decided to ensure that only one user exists. So to bypass this restriction, we can get all the rows with the trick seen above, and then limits this number using the SQL keywords limit. So we're gonna go forward to the second example. We're gonna hit here. We're gonna type most of the same previous payload or injection, but here we add the limit of 1 encoded, and as well we can do a random as password. So we click submit, and as we see, we have been successful in our second example attempt. Moving forward towards the third example, in this example, aware of the risk of the SQL injection, the developer decided to block single quotes by removing any single quote in the query. However, there's still a way to break out of the SQL syntax and not inject arbitrary SQL. So to do this, we need to think of the query, select from users where the username equals username and password equal password. The problem is that we cannot in theory break out the single quotes from that query. However, if we inject the backslash, the second quote in the query will be escaped and will be closed by the third one. And yeah, using this, we can use the parameter password to complete the query and return always the true statement. So we're gonna head forward toward this third example. We're gonna type in the, oh no, it's the other type of slash, this one. And here we're gonna put our payload, which would be or 1 equals 1 encoding. If we hit submit, you see success. We've been successful in our third example. So for the fourth example, in this one, the developer puts a part of the query directly in a parameter. So it's really rare in traditional web applications, but sometimes can be found in web services, especially for mobile applications. So here we're injection directly in the where statement, and we can manipulate the retrieve anything we want. So we can go ahead and come here to the for. We see we have the ID and the name hacker, but we're gonna add something here to the payload. So we're gonna type in our usual payload, which would be or um, 1 equals 1 encoded, and as we see, we get all the query database information. So for our fifth example, in this one we're injecting after the keyword limit on MySQL. This type of injection can only be exploited by using union select if there's no order by keywords used in the query. So order by keywords need to be located before the limit keyword in order for the query to be valid. So we cannot get rid of it using comments. So we're gonna do limit on a payload, for example, number 5. So we come here, we come to the payload, and we add union all select. This is our query. Everyone from users. And as you see, we get all the information from the users. Moving forward to example number 6, this is another example of SQL injection, but this time after the group by keywords, union-based exploitation can be used by to exploit this type of issue. So, so we can go ahead and come here to example number 6, and as we can see, we have group equals username. If we remove this at all, and we enter, we get all the information. Moving forward to example number 7, in this one, 2 queries are performed, and the first one retrieves the user's details based on the parameter ID, and the second one uses the username from the previously retrieved to retrieve the user. So we can use the following statement that would be extract value and all the information that goes ahead. So we will try to add that to the payload in example number 7 in the URL. So we just remove this right here, paste this information right there, and we hit enter. And as you see, this is a good way to demonstrate that the page is vulnerable to SQL injections and that we can gather information based on the database. So as you see, we get the same exact error message that the guide does. So yeah. Moving ahead, example number 8. This one is vulnerable to second order SQL injection. Instead of directly injecting our payload into the request, we will first insert it in the database using our first request, and then trigger the payload in the second request. The first request is not vulnerable to SQL injection, only the second one is. However, we do not directly control the value used. We need to inject it using the first request. This issue comes from the fact that the developer trusted the values coming from the database. Each attempt will need 2 steps. First, create a user with a valid payload, and then access the user information to trigger our payload. If we want to be efficient, we need to automate this process using a simple script, and the payload can be as simple as a union-based exploitation. So now, to do this, and we will first try to create a user. It could be, we'll add create a user with your payload, so the user will have our payload, which would be or 1 equals 1 on the encoding sign, and the password could be whatever we want. Create user. You see here, the code is not yet injected because we have to create another user, a random user, so put a random name. But in the password area, we are gonna add our or 1 equals 1 encoding payload. So once we create this user, you can see that well, there the payload is executed. So yeah, once we have both of these users, the payload can be ran, since the one's user password is the payload and the other one executes it. So now moving forward to example number 9. This one was first published in 2006 as a way to bypass MySQL real escape string. It relies on the way MySQL will perform escaping. It will depend on the char set used by the connection. If the database driver is not aware of the char set used, it will not perform the right escaping and create an exploitable situation. This exploit relies on the usage of GBK. GBK is a character set for simplified Chinese.
Using the fact that the database driver and the database don't talk the same char set, it's possible to generate a string from a quote and break out of the SQL syntax to inject the payload. So using the string \x bf quote encoded as that, it's possible to get a single quote that will not get escape properly. It's therefore possible to inject an always true condition using that and bypass authentication. So yeah, we're gonna do that right now.
And to finalize this ninth example, using the JPK character, we're gonna paste it here in the username. This is the JPK character, and we just had written the password, and as you can see, we had success entering the SQL injection. That will conclude the SQL injection section of this lab.